step-by-step solution to the section on friction, which is question 4, and we'll be focusing on the February 2022 past exam paper. If you look at the question, the first question is to list 3 disadvantages of friction, and the second question involves doing calculations on the inclined plane. Let's take a look at the solutions. So 4.1 says list 3 disadvantages of friction. So firstly, friction produces heat in many parts of a machine, and this is a disadvantage because it reduces the efficiency of a machine. Point number 2, the heat generated by friction in a car can cause the tires of a car to slip. The next point is that friction produces a lot of noise, and lastly, friction causes wear and tear in moving objects. Question 4.2. A granite block with a mass of 0.1 tons rests on an inclined plane of 20 degrees toward the horizontal. So the key word here is inclined plane. When it comes to friction, there are 2 types of planes that we have. We can either have an inclined plane or a horizontal plane. When we have an inclined plane, it is always followed by an angle to the horizontal. This is a plane that simply has a slope. In other words, the object is moving uphill or downhill. Next thing it says, take the coefficient of friction as 0.36. Now let's look at our given information. Firstly, we are given the mass. The mass here is 0.1 tons, right? We cannot have mass in tons, we need to have mass in kilograms. So to convert from tons to kilograms, we're going to multiply by 1000. So 0.1 times 1000, my mass to be used in this calculation is therefore 100 kilograms. The next thing, I have an angle of 20 degrees, so that is how I know I'm dealing with an inclined plane. And lastly, I have the coefficient of friction as 0.36. This is the symbol which we use for the coefficient of friction. It is called mu. Let's look at our solution. The next thing you need to do is actually draw a diagram. So when I draw this diagram, I first start by drawing the inclined plane. So this is my inclined plane. And now we find that inclined plane is simply going to have an angle of 20 degrees. Okay, so it's 20 degrees to the horizontal, and angle for 20 for the mass lies on the top or the vertical side. So this is where my object has the mass. So this is where I have the mass of 0.1 tons. So if an object has mass, then an object has weight. So the weight is going downwards, and you have the force of gravity. So the object is now being pulled 2 ways, which is being broken up into a vertical component, and it is being broken up into a horizontal component on an inclined plane. Okay, so after we break these 2 components up, we then need to find what each component is. So the vertical component makes an angle of 90 degrees to the plane. So there's my plane here. So this portion is the plane. This is the vertical component. I have an angle of 90. So the next one is, this is the plane, and I have the horizontal components also moving with it. Okay, and they are adjacent to each other, so this is known to be parallel. So the vertical component is perpendicular to the plane, while the horizontal component is parallel to the plane. So this object needs to be in equilibrium. I have a vertical force coming down, so I have a vertical force going up. This vertical force is known as my normal reaction force. So these are the basic components that act upon an object that is placed on an inclined plane. You have a normal reaction force going vertically up. You have your weight, which is broken up into 2 components, a vertical and a horizontal. Your vertical is perpendicular to the plane, while your horizontal is parallel to the plane. Okay, question number 1 says, calculate the following. 4.2.1, the weight components, right? So we are specifically looking for the weight component, which is now perpendicular to the inclined plane. So when they are referring to the weight components, so the force that has weight is the force of gravity. So on the object's mass, you have gravity acting downwards. So therefore, we should now remember that weight is calculated as mass times gravity. Right? So let's look at how we would calculate this perpendicular component, right? So since I have the vertical components, in order to determine whether it's cos or sine, I need to label the three sides of my triangle. So on this side, I have the angle here, as you can see. Across the angle, this side here is known as the opposite side. The side next to the angle is known as the adjacent side. And here where I have the longest side joining these two right angle triangles, this here is known as my hypotenuse. Alright, so if I look at the vertical components, the sides that I now have for the vertical components, I have the adjacents, and since I have the mass, I should be able to calculate the weight, and the weight is found on the hypotenuse. So according to the acronym SOHCAHTOA, we should now remember that cos is simply adjacent over hypotenuse. That is why the vertical component here is weight is equal to W cos theta. Okay, how did we calculate weight? We said weight is calculated as mass times gravity times cos theta. Let's substitute our values. Remember, the mass in kilograms is not 0.1 tons, but the mass in kilograms is 100. The force of gravity is 9.8, and we now have cos, and the angle for the weights and the angle for the plane are both the same. So your mass is placed on this plane, which has an angle of 20. Therefore, your weights will be placed at an angle of 20 degrees. So when I input these values in the calculator, the vertical component is going to be 920.899 newtons. Please remember, in engineering science, we don't have all answers to 3 decimal places. Next question, calculate the weight component parallel to the plane. Okay, so we now learned that the weight component, which is parallel to the plane, is the horizontal components. I have my angle here, which is 20, and again I start with the 3 sides labeling for the right angle triangle. The side directly across is known as the opposites. Okay, here I have my weights. This is the longest side on the triangle, and this is my hypotenuse. So now the horizontal components, the sides that I have for horizontal is opposites and hypotenuse. So that is why I'm now going to use sine theta, okay, where sine theta is calculated as opposites over hypotenuse, right? That is why the equation here reads the weight component parallel to the plane is W sine theta. So you should remember on an inclined plane that the vertical component is calculated using cos, as we did in the previous question. The horizontal component is calculated using sine. Alright, and we now know that the formula to calculate weight is mass times gravity. So remember, the mass in tons should not be used in the calculation. We need to keep the mass that is in kilograms, the correct SI units. So here the mass should be 100. So we're going to say 100 times 9.8, and we're going to multiply by sine 20. And if you input this value into your calculator, you should get 335. So that's 335.180 newtons. The next question calculates the frictional force. Okay, in order to calculate the frictional force, we need to use the formula. Coefficient is equal to frictional force divided by your normal reaction force. Okay, according to my question, we are provided with the coefficient. The coefficient here is 0.36. We do not have the frictional force as yet. That is what I'm trying to find. And what I now need to look for is the value for the normal reaction force. And we said this vertical component going up is my normal reaction force. So there should be a way for us to calculate this normal reaction force. Okay, since the object is in equilibrium, right, we should find that the normal reaction force going up, right, should equal to a vertical force coming down. And if I look very carefully on this diagram, I have one other vertical force coming down. It is this vertical component from your force of gravity or your weights. So your normal reaction force going up equals to the vertical components coming down. And we now know that this vertical component is calculated using the formula W cos theta. So we calculated this vertical component as W cos theta in our previous question, and when we put it on the calculator, we got the answer as 920.899. Right? When I now substitute into my equation, back into the formula, coefficient is equal to frictional force divided by the normal reaction force. My coefficient is now 0.36. The frictional force is what I'm trying to find, and this is the symbol for frictional force. You will find this formula on your formula page. There's attached at the end of the question paper. Right? And we now know that the normal reaction force, which is equal to this vertical component, or the weight component parallel to the plane, it's going to be 920.899. So we can substitute it into this equation. So if I have to make the frictional force to substitute the formula, the frictional force now becomes 0.36 because I need to cross multiply. So it's 0.36 multiplied to 920.899, and the value that I will now get for the frictional force is 331.524 newtons. Okay, let's take a look at question 4.2.4, and this question says, let us calculate the minimum force required to pull the block up the plane. It is very important to know the direction in which the object wants to go. Alright, so if we look now, what we are going to do is, first of all, look at the equation that is needed to be used. Right? According to the Newton's law equation, we generally use accelerating force is applied minus friction, and in this case we have one more horizontal force, which is the W sine theta. Right? So here you have see that there's a blue arrow pointing upwards because we need to know in which way the object wants to move. So since the object is going up, we need to have the applied force taking the object upwards, and then next we need to place the force of friction. As you can see, friction moves in the opposite direction. Therefore, in this case, friction needs to move downwards. So if you look here very carefully, you will now see that the force applied and the force of friction will move in opposite directions. Right. Next, it is important for us to determine now how we get this positive and this negative sign. Okay, forces are vectors, they have magnitudes and directions. The directions are determined, or the signs are determined, by whether they are moving north, south, east, or west. Okay, so as you can see, if it's moving north, it's positive. If it's moving east, it is positive. If it is moving south, it is negative. And if it is moving west, it is negative. So when I look, I can now see the applied force is moving east. That is why the sign here is positive. The force of friction is moving west. That is why the sign here is negative. And the next horizontal component that I look at is the force of gravity. And remember, this component was calculated using W sine theta. Okay, here we can also see that it is moving west. That is why the sign is negative. Right. Next, we need to determine whether or not the object has an accelerating force. To determine that, we need to see if the object is accelerating, if there's a velocity, and if that velocity is changing. So according to my statement, the object is moving from west. If it is moving from west, that means there is no motion. The initial velocity is 0. If there is no velocity, then that means there is no acceleration. That is why our accelerating force here is 0. Right? So remember, acceleration is the rate of change of velocity. Right? So we said we are subtracting this frictional force because it is moving west. In the previous question, we calculated the frictional force as minus 331.524. We are also subtracting the force of gravity. It is pulling the object down, so it is moving in a negative direction. And in the first question, we calculated this horizontal component parallel to the plane as 335.780 newtons. Okay. Next, I want to calculate the applied force. How am I going to do that? I need to make the applied force the subject of the formula. I leave the applied force on one side. I take all other values over to the other side. So when I take this 331.524 over to the other side, I need to change the sign. The negative sign is going to become a positive. the W sine theta, which is minus 335.780. Once it goes over onto the other side, it also changes from a negative to a positive. So to calculate the applied force, I'm now going to say positive 331.524 plus 335.780, and I'm going to get the applied force as 666.740 newtons. So please remember, when we want to calculate the applied forces, pulling or pushing on the objects up or down the plane, we must draw a diagram. Okay, we must remember that the applied force and the frictional force are going to move in the opposite direction. This force of gravity, which is your horizontal component, which is W sine theta, is always going to point downwards, alright? It's always going to pull the object down. So gravity is always going to pull the object downwards like this. So that is why the W sine theta is always going to have a negative sign. It always helps to draw our Cartesian plane, place north, south, east, and west, and then place the positive and negative signs to help us determine in the equation if the sign should be positive or negative. If you look very carefully on your formula sheet, this formula that I've just written here, force accelerating equals to applied minus frictional force minus W sine theta, is not on your formula page, so it is very important for you to learn this formula in preparation for the exam. Thank you for watching today's lesson.